So in this next section here, 7.4, what we're going to do is we're going to take the properties and the definitions that we learned in the last section, and we're going to apply it to some problems and some proofs. Okay, so for the first problem here, it's a proof, and it basically says that HEAD is a parallelogram. That's what this symbol means. And so you have the properties of a parallelogram in this big shape here, and then you know that CE is congruent to DR. So by subtraction, I know that, for example, this has got to be congruent to this. That's what I see when I see CE is congruent to DR. What I'm trying to prove here is I'm trying to prove that HC is congruent to AR. And when I look at that, I'm kind of looking at where the action is as far as some of the properties and some of the given information there. And I think what I'm going to need to do here is prove that this triangle is congruent to this triangle here. Okay, so let's go ahead and try doing this proof. I know that I got some givens, and then as a result of, well, let's go ahead and get this in here. So CD is congruent to RE, and of course was by subtraction. And now I can go ahead and do some things with the parallelogram. So I know that, for example, I know that HD has got to be congruent to EA, because if I have a parallelogram, then the opposite sides are going to be congruent. So I have this, this congruent to this. And I also have opposite sides parallel to each other, so I know that these two are parallel. So in step 4, I can say that HD is parallel to EA. If I have a parallelogram, then the opposite sides are parallel. And because of that, and because I can do alternate interior angles, let's show you where those are. Right here. I can say now that angle HDC is congruent to angle AER. That's because of what we learned in section 1 and 2, that if I have parallel lines, then the alternate interior angles are congruent. And now I can say that the triangles are congruent. So triangle HDC is congruent to triangle AER by side angle side. What steps is that? 2, 3, and 5, I believe. 2, 3, 5. And now I can just do that these are congruent to each other. And that would, of course, be by CP, CTC. Okay. Let's move on to the next problem here. So now we're given that this figure here, TRAP, and it's got to be in this order. So it's got to be T, then R, then A, then P. Okay, that's how the lettering works. But it's an isosceles trapezoid, so I know that. Here. I know that the top and bottom are parallel to each other, and that angle T and angle P are, this is 2x squared plus 58, this is 185 minus 23x. From this I can get an equation, because I know that these two have to be supplementary to each other, so I can go ahead and say that 2x squared plus 158 plus 185 minus 23x is got to be equal to 180. And I can go ahead and solve this for x, bring everything over to one side, factor it. I believe x ends up being, I'm going to shortcut this here, 7 or 9/2. You can go ahead and try that. I believe that 7 doesn't work. When I plug it back in, I believe I end up with a negative for this one here. And so 9/2 does work, and then I just plug it back in, and I know that the angle P has to be the same as angle A, because the base angles, the lower base angles of this isosceles trapezoid have to be congruent to each other. Okay, and that's another property that I just used there. Okay, number 3 here, it's given C is -1, +8, so 1, 2, 3, 4, 5, 6, 7, 8. It's going to be letter C. D is going to be 0, +3. A is 9, 1. And you're supposed to find possible coordinates for letter B. Now, here's where things get kind of interesting, because it didn't specify the order of the letters. So I could do like C, then D, then A, and then so I know that, for example, this last one, let's call it B, would have to be somewhere around here. But I could also do it like C, then A, then it would be something like this, B, and then D, and then C, like that. I could do something like that, so I could end up with another B over here. And then, of course, there's one more that I could end up with, like, way up here. So let's just talk about how to get the first B, and then I'll let you find the other two. So let's do a quick erase here. And so the first B here, what I have to recognize is that one of the properties of a parallelogram is that the opposite sides are parallel to each other. So that means that these two sides from here to here and these two sides from here to here have the exact same slope. So if I go down some amount and then over 1, then that would be the same as going down and over 1. That these two have to have the exact same slope. Or I could go left and then up the same amount to find where the actual B is. Okay, and that's really all I'm going to do when I'm looking for these points, is I'm using the slope and I'm just going to count. So that B in particular will end up being 10 comma, oh no, that one's going to end up being 8,6. There is another one at 10, -4. That's the one that we said was down here, kind of. I believe it's probably up a little bit more. And then the last one is going to be -10, 10, and that was going to be the one that was way like out here somewhere. Okay. Let's flip over to the backside and try a few more of these problems, just for laughs and giggles here. All right. Okay, here we are on the backside. Let's try problem number 5 here. It says that ABCD is a rectangle, so we know we have some properties of a rectangle. And it gives you a couple of the coordinates A and B, and C, it tells you that the x-coordinate is going to be -2.5, and then the y value, we don't know what the y value at C is, and then we don't know D at all, so let's find that. So the first thing we have to do is we need to try to find this y value at C. And the way we're going to do this is we got to find the slope of this thing first. The slope of AB is going to be, we can find this, it's going to be 5/8, which means because this is a right angle here, and that's one of the properties of a rectangle, we know that this slope has to be equal to negative 8/5. Because that's the slope there, I can plug it into the slope formula. So it's going to be negative 8/5 is equal to the change in the y values between the b and the c, and divided by the change in the x values. So it would be y minus negative 1, so y plus 1, over negative 2.5 plus 5. Cross multiply, solve for x, or sorry, solve for the y. Your y value is going to end up being negative 5. So make sure you do the work on that, just to make sure that you know how to do the work on that, but you're just basically going to cross multiply here and cross multiply there. Once you find that y value, and it's going to be negative 5, it's just a matter of using the slope from here to here and then doing the exact same slope, because these two sides are parallel to each other, from here and then in the x direction this way. And so when I count that off, the d is going to end up being, and it doesn't actually fit the diagram very well, sorry about that, but it's 5.5 comma, I believe the y value ends up being 0. Okay, one last problem down at the bottom here. Got this rhombus formed by joining two equilateral triangles. I believe this is supposed to be triangle symbols. Sorry about that. Not sure what happened there. But I'm going to end up with a rhombus, so let's draw that. And these are going to be equilateral, two equilateral triangles there and there. Okay, and then this is going to be our HOM, and it says HM is drawn so that the intersection, so HM is right here, is point S. So that's S right there. And we know, of course, that this is a right angle here. I'm not sure if that'll help us. But it says that MHR, which is right here, is 3x plus 21. We know that one of the properties of a rhombus is that the diagonals bisect the angles. That's one of those properties for a rhombus. And so we know that because this is an equilateral triangle, we know that this must be equal to 30 degrees. So I can set 3x plus 21 equal to 30 and solve for x. X will end up being 3. And then I can plug this in for SO right there. That tells me that SO is going to be 10. And I know that this has to be 10 also, which means that one of the side lengths for this equilateral triangle is going to be 20, which means that all these sides are 20, 20, 20, 20, which means that we know that for a rhombus, all the sides are congruent, and therefore the answer must be 80. Okay, hopefully you understand what we're doing here. We're kind of just taking the properties and we're just using these properties to solve various types of problems. Okay, good luck with the problems on the homework. All right.